Hi guys, so we are going to review what I am looking for your element project. So if you go to the website found on Google Classroom, of course, go to the chemistry tab, scroll down to elements, you'll see that we have the periodic table of elements. That's what you guys should have already completed and filled in. And then we have the if you were an element. Now this is the only place I'm going to post the directions and the rubric for the project. And I do have a few sample projects here. I'm waiting for a few more images to upload. So hopefully later today or tomorrow, you guys will be able to see some sample projects, but I will show you some in this video later. So we have, if I were an element, you're going to be taking the properties of yourself and trying to figure out what element would you relate yourself to. So you can do this project in any way you can think of. It just cannot be a Google slide and it cannot be a regular poster. So you can use poster paper to make your project, but it can't just be a straightforward, this is my project, this is the information. You can't just make a list of information. So you have to be creative with how you're doing this. You can do a children's book. You can do some kind of artwork that has all the information in it. I have poster on here, but what I mean is you can you have to be creative with that poster. So you can use poster paper, like I said, but you have to do something different than just listing the information. You can make a drawing, a 3D art, a wanted poster, Facebook or Instagram profile. You could do sketch notes. It should be very neat and colorful. And I will show you some other ideas in addition to these that you can do. But if you have another idea that you're not sure about or that's not on this list, make sure you ask me first, because sometimes I do have students that have great ideas, but I know that it will take either too much time or finding the materials is going to be impossible. So there may be some reasons why I'd want to turn down your idea, or maybe it won't do what we need it to do. So make sure you run an idea by me first if you do want to do something other than what's on this list. Also, the more creative you are, the more extra credits you are going to get. So I do welcome ideas that are not on this list or ideas that I'm not going to show you. I just want to make sure it's something that is doable. So for this project, like I said, you're going to take properties of the elements. Let me show you the periodic table really quick. So here's our periodic table, which you have already colored in by now. And we've already learned about the properties, how to read the periodic table. So some of the things is increasing reactivity goes this way. It also goes down. So the most reactive elements are going to be over here or this column. So you can take reactivity as a property. For example, if you're walking down the hall, somebody brushes your shoulder, are you going to react in a negative way? Are you going to explode at them? So these elements are very explosive. Because they want to be with other elements. They can't be found by themselves. So is that your kind of personality? Or you can take reactivity as you see somebody fall in the hallway. Are you going to be the first one to run over there and react and try to help them and help them up? Or you see a new student in school.
Maggie Kinkell, if you're in the building, please contact the main office. Maggie Kinkell, if you're in the building, please contact the main office.
Are you going to try to introduce yourself and make sure that that new person feels welcome? So that would also be reactive. So are you somebody that makes friends easily or feels like you always have to be around somebody else? You don't like being by yourself. You always want to be with somebody else. That would also be a reactive property or a bonding property. So these elements, they don't want to be by themselves. They want to bond with other elements. They want to be with other elements. Same thing with some of these elements over here. So like we learned, the seven valence electrons wants to have one more valence electrons. So a lot of times these elements are going to be bonding with these elements, or we have 2 would want to bond with 6, for example, because we want to get to the total number of 8 valence electrons. which means this column that has 8 valence electrons, they don't want to bond. So this is the one group that usually they're found by themselves. Well, they're not bonded with other elements, so they don't make molecules, but there's other properties about those that might be interesting to you. So if you feel like you're very energetic and electric, for example, these are our noble gases, but when we run electricity through them, so like neon, argon, krypton, these are the gases that are found inside of neon lights. So maybe you feel like you're very bright, or maybe you're very active. Maybe you're moving around all the time. Maybe you're all over the place. You'd want to be a gas because gases are constantly on the move. Maybe you fill a room. So when you walk into the room, your teachers know you're there. Your friends know you're there. So gases fill rooms. They're always moving. They're active. If you play a sport, a gas might be a good one that you can relate to, because athletes have to be very mobile. You have to be fast. You have to run around a lot. You also have to run around. You have to be in a bunch of different places at once. So well, maybe not at once, but you have to be in a bunch of different places. So you can take that as you are a student where you have to be at school, you're a child, you have your parents, so you're a son or a daughter, you are an athlete, so you have to be out on the field, you have to go home and do your studies. So you're constantly doing things, you're all over the place. You could also take the abundance of an element and relate it to the same way that I just did. So if you are all over the place, then maybe you want to pick an element that has high abundance, where it would also be all over the place. So like nitrogen, for example. Nitrogen, it makes up most of our atmosphere. It surrounds the earth. It is all over the place, literally. So nitrogen could be it is also a gas. So gases are also transparent. So maybe you are somebody that just lets everybody in. You're very open. You let everybody know what's going on. That would be a good transparent property. So you could choose a gas for that. Maybe you're an athlete where, like a football player or soccer player, where you need a lot of muscle and strength, or gymnast even. Maybe you want to go with a metal, because metals are very strong and supportive. Or maybe you're not supportive. Maybe you're not strong physically, but emotionally. Maybe you're the person that all of your friends go to for support. Or if you're a gymnast, metals are, just like we set up here, they are malleable and ductile. So malleable means I can hit it with a hammer and I can start forming it into different shapes. You need to be very flexible and be able to bend and move into different shapes. So if you're a gymnast or a dancer, so that would be a good, metal might be a good option for you. So there's lots of different ways that you can relate your properties, your personality, to an element on the periodic table. You need to find 5 ways that you relate to any one of these elements. And of course, I'm here to help you if you need the help, but I do want you to try to do it on your own. Some other things that are popping into my head right now is oxygen, for example, or nitrogen. I do have some twins in my classes, and they bond with themselves. So you're always going to find, not always, but oxygen bonds with itself. So the oxygen in the atmosphere that we breathe is O2. Same thing with nitrogen in the atmosphere is N2. So it's bonded with themselves. So there's 2 of them. So you can relate as a twin that way. If you're really close to your family, you could also bond with itself. So you can say that nitrogen bonds with other nitrogens. So it's like you bonding with your family. You're always with your family. So hopefully that gives you guys a few ideas on how to take your personality and your traits and relate it to some of the elements. I also gave a list of things that you can look at to try to relate. Let's get back up there. So bonding is the first thing that I have on here. So like I said before, with bonding, and now that we understand how bonding works a little bit more, hopefully, do you form friends easily? So if you form friends really easily, and that's a big personality trait of yours that you'd want to relay, then you'd want to find an element that also bonds very easily. So it can be one of those first elements, the alkali metals, the alkaline earth metals, or one of the gases or non-metals that are not in that very last column. So as long as you don't have 8 valence electrons, it wants to bond with other elements. If you're highly reactive, or if you're calm or don't react very much. So if you're calm, you don't react very much, maybe you want to be in one of those noble gases, the column 18. But if you're highly reactive, you're explosive, the alkali metals, they are very reactive. They're very explosive. They have to bond with other elements. So maybe you'd want to be an alkali metal. You could look at the density of the elements. So if you're a dancer or a swimmer or a surfer, then maybe you want to find an element that, and you feel like that is what really defines you, then maybe you want to find an element that has a very low density, something that would float on water. So you can say, I'm a really good swimmer, I'm a really good surfer, or even dancers, they have to float through the air. So you'd want to find so you can relate yourself to a low density element. If you're down to earth, you're like very relaxed, then you could use a heavier element. So you could find ways to relate all of the properties of elements. You can just kind of twist it to make it relate to you. States of matter. We have solid, liquid, and gas here on Earth. So if you are a solid, you could take that as you're either strong, you're physically strong, mentally strong, or you can make it as like you usually have a wall up, you don't let people in very easily, you're kind of secretive, you can't see inside you. So solids are usually not transparent unless you do carbon, and then carbon has many different forms, and you can kind of twist that around to make it you. Gases are transparent. You can see through them. We don't see them at all. So maybe you have one of those personalities where as soon as you meet somebody, they already know everything about you. Maybe you are kind of lost in space sometimes, where you, or lost in thought rather, where you have a lot of things on your mind, or you're always thinking about something else. So you could say that you're gassy, you're a gas because of that. You can relate gases to religion, or you can even say that like if you fill a room, we all know that you're there, you're all over the place, gases fill a room. Or if you pick a liquid, you can, if you go with the flow, you do what everybody else does. You just kind of go along with what people are saying or what they're doing, so you can go with the flow. Or if you pick the metal, which is mercury, that's a metal liquid. That metals usually are not liquids, so that would be like a nonconformist. You don't go with the flow. You want to be yourself. You're unique. You could also relate to elements by abundance. So abundance is like how much of there is, or how little of it there is, or its usefulness is, what it's used for, how useful it is. So if you're in a ton of activities, you do 3 different sports, or even if you do one sport but every season, or you're never sitting at home, you're always outside doing something, playing with your friends, or all over the place, that would be something that is high abundance. You're never calm, you're never sitting still. Or you could find an element that is low abundance. Maybe you only do 1 or 2 things. You go to school and then you go home and you play video games. You don't move from the couch. Maybe you're strong and supportive. And like I said before, strong can be mentally strong, or it could be physically strong. Supportive could be, again, mental or physically. Maybe you're there for your friends, but maybe you also are on the cheer squad and you're the bottom, you're the base. You have to be the support for your team when they climb up to make a pyramid. Maybe you would describe yourself as beautiful or shiny, bright. So those would be good transition metals. So your transition metals are gold and silver and platinum. Maybe you feel like you're rare or unique. So you could look for, again, that would go with abundance, something that is not very abundant, it's hard to find. Or I've definitely had some students that feel like that they are expensive. They like a lot of money spent on them, or they spend a lot of money. So again, you can find out how much. We know that platinum would be one of the more expensive settings for a ring, for example, or for jewelry, compared to silver or even gold. So hopefully this will help you a little bit more. Start thinking about some of those ways that you can relate some things, some properties about you. You need to come up with 5 ways that you can relate to one of these elements. The way you're going to get graded, so the very top on your model somewhere on your presentation, you need to have a Bohr model drawing, a Lewis dot diagram, and a picture of your element. So I'm going to show you what those are. Based on the elements, though, based on you filling out the periodic table, you should be able to understand how to do the Bohr model. So I will show you on the back, actually. We now learned, we understand that, remember, the periods tell me how many orbitals there are. So if any, depending on where my element is located, that's how many rings there are going to be. So let's just do, let me do a smaller one just so you can see it. Lithium, for example. Lithium has 2 rings. So when I'm doing my Bohr model, I know that I'm going to have 2 rings. Sorry, I just drew this. So 1, 2. All right. Then I see that there is a total of 3 protons. And if I look over here, if I round the 6.94 to the closest whole number, I would get 7. So my mass is 7 and my protons is 3. So this is lithium. So if my mass equals 7 and my protons equals 3, that means I would have 3 positives. 1, 2, 3 positives. And to find the number of neutrons, remember, I take my mass and subtract the protons, because my mass equals protons plus neutrons. So if I get rid of my protons, I'm left with just neutrons. So that means I have 4 neutrons. So I'd have 1, 2, 3, 4. And then remember, the number of electrons is going to be the same number of my protons. So I always start with 2 on the first ring. So 1, 2. And then I need 3 total. So it would be 1, 2, and then 1 more would be my 3. And I could put my minuses in there. So that's how I would do my Bohr model. But just in case I wasn't too sure and I wanted to double check, I could also type it in, Bohr model of lithium, go to images, and you'll see that they did the exact same thing that I just did. So 3 protons, 4 neutrons, but I do want this drawn out. You can't, up to the number 10, you should have them, all the circles drawn out. So it would look something like this. And then you'd have 1, 2 on the first ring, and then 1 more on the second ring. So that would equal a total of 3 electrons, 3 protons, and 4 neutrons. And you can see it for all different angles. I want it to be just like this. Your circle, this is hand drawn, and you need to make the circles straight, not crooked circles. So you're going to use something to trace. I have plenty of things in my room that you could use to trace to make those rings. Or you can also, if you're at home, I'm sure you have plenty of things that are circular that you can trace around to make the rings for the electrons. All right, the other thing that you need to do is the Lewis dot diagram. So now with the Lewis dot diagram, That has to do with how many valence electrons there are. So we would take, let's use lithium again. Lithium, we take the symbol. So lithium symbol is Li, Li, and that goes in the middle. And then based on the valence electrons, which would be up here, so we're looking up here. So remember, these are the valence electrons, the numbers that we circled. Circle the number of valence electrons. So there's one valence electron in a lithium. So that means there's going to be one dot. Let me start over here. All right, so if we look at a, let's say, oxygen, for example. Oxygen, I look up, has 6 valence electrons. I look over, it has 2 rings, and it would have a total of 8 protons and 8 electrons. Let's just look at oxygen both ways. So we have 2 rings for oxygen. 1, 2, 3, 4, 5, 6, 7, 8 protons. I didn't look at the neutrons. I'd round up 15.999 to 16. So 16 minus 8 equals 8. So I have 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. And then I also said that I have 8 electrons. Remember, 1, 2 on that first ring, 3, 4, 5, 6, 7, 8. So there would be 6 on the outside ring. So that would be my Bohr model of oxygen. And then my Lewis dot diagram, I start with the symbol O. Okay, O. I look up, I see that there are 6 valence electrons. So I start with 1, 2, 3, 4, 5, 6. And that would be my Lewis dot diagram. So just to make sure that we're correct, let's look up lithium and oxygen really quick. The Bohr model of oxygen, remember I said had 2 rings, 2 on the inside and 6 on the outside. So we have 1, 2 rings, 1, 2 on the inside, first ring, and then 1, 2, 3, 4, 5, 6 on the outside. All right, and then we have the Lewis dot diagram. And remember I said for the Lewis dot diagram of oxygen, it's the O, and it has a total of 6 dots around it. So here's my O, 1, 2, 3, 4, 5, 6 dots around it. That's for my Lewis dot diagram. And then we also did the Lewis dot diagram of lithium, which is the Li with 1 dot because it had 1 valence electron. None of those are lithium, so I have to wait for the images to come up. And here we have lithium, Li with a 1 dot. All right. So hopefully that is pretty straightforward. You guys can look it up, but you should also be able to do that on your own now. All right, the next one that we had to do is a picture. So either the picture of the element or a picture of the element in use. If you're doing a gas, you can't draw a picture of a gas. It's clear. So you need to find a use of it. So for example, we just did oxygen. So you want to start thinking, what are some things that we use oxygen for? We breathe it. So that would be one way that we could represent it. We could have a person just smelling. Oxygen is found in water, but it's bonded. But here would be a great example. Oxygen is put in tanks when you go diving so that you can breathe oxygen. Oxygen is in the air, so you could put a picture of the air. I don't want the molecule. So you can't use a water But what they're showing here is the bubbles coming out are oxygen bubbles. Here's a picture of oxygen in the atmosphere. Breathing. So somebody breathing, they breathe in oxygen. So you can find multiple ways to represent the gas oxygen because we can't see it. Lithium is found in batteries. But you could find a picture of lithium, which is a metal, or you can find the use of lithium, which would be right down here. Perfect. The batteries, just like the batteries that I gave you. And you can see right on the battery, even if you look at the battery that I gave you, it'll say that it's a lithium battery. All right, these you need to look up. Density, you just type in density of lithium, density of oxygen, whatever element that you're doing. Reactivity, does it bond or not bond? Now, this is something you're going to find on the periodic table. Remember, basically everything bonds with other elements except for this column here. These guys, they have 8 valence electrons. They are stable, they're happy, they don't want to bond with anything else. So these ones are not going to bond. All the other ones bonds, but I also want you to tell me if it bonds, how likely is it to bond? These guys are so reactive that they're explosive. They have to bond. These guys are not happy by themselves either. So they're going to bond with other elements. These ones in here, they do bond. They're just not quite as explosive as like this first column, the alkali metals. That's all I'm looking for. You're not going to be able to find that online. Abundance on Earth, you type that in. How much is there? Color, again, you're going to have to search that. Some elements have multiple colors. Some are transparent. They're clear. Category, metal, non-metal, metalloid, you're going to find that on the periodic table that you colored in. You already labeled your metals, non-metals, and metalloids. You also labeled your liquids. So down here where it asks you what shape it is it an amorphous shape, crystalline shape? Is it a solid? Is it a liquid? Or is it a gas? Before I go down to the shape, you have conductivity. Is it conductive or not? And again, one of the properties of metals is that it conducts heat and electricity. So conductive elements would be your metals. The metalloids are semiconductive, and the nonmetals are not conductive at all. So you're using your periodic table to determine if your element is conductive or not. Shape at room temperature. So liquid or gas, those are straightforward. You need to just say that it's a liquid, so it takes the shape of the container. It's a gas, it has no definite shape or volume. It fills whatever container it's in. Solid, an amorphous solid or a crystalline solid is the structure that the atoms make when they're bonded together. So and some of your solids could be either or. So you're going to have to do a little bit of research to find out what it is. But I just want to show you to clarify what a crystalline solid versus an amorphous solid is. So if you open this up, this is a good picture, a good example. Crystalline solids make a pattern. So it's repeated over and over and over. They make a really pretty pattern. And this is where we get our crystals from. An amorphous solid connects just like the crystalline solid does, but there's no pattern to it. They're just kind of like all over the place. Let's see if we can get another image just so that you guys kind of have a little bit better understanding. So here's another image. It's pretty similar. All right, so you can kind of see crystallines, they make a pattern, repeated pattern, where amorphous is just kind of all over the place. You are just looking up to see what kind of shape does your solid make. Does it make an amorphous solid or shape, or is it a crystalline shape? All right, then you have to identify the elements. So symbol, atomic number, atomic mass, number of protons, electrons, neutrons. You should be able to figure all this out. Look at your periodic table, what period it's found in, and what family it belongs to. All on the periodic table, all need to be part of your project. Then you need to look up 5 interesting facts about the element. You need to explain the 5 ways that you relate to the element, and then it needs to be neat, creative, and you have to present. Most likely, we're going to be presenting with Screencastify this year. All right, so really quick, I'm just going to show you a few samples. So in addition to the ones that I already posted on the website, we have this is one of my favorite ones. So a student last year, she wasn't as creative with writing necessarily, but she was very artistic and kind of thought outside the box. She wanted to make her project really unique. So she made it where it's a riddle up here. So you have to kind of guess based on the properties that she says and how she describes it. You have to guess what her element was. And then when you open it up, I love how it just flies open. And instead of trying to think of creative ways to relate herself to it, she literally just listed everything. So here's the density, here's the conductivity, here's the color, its shape. Some fun facts are over on this side. The picture of it, the atomic number, the mass, the symbol, so everything's there, your Bohr model, Lewis dot diagram. So we have everything that she needed to right here. But it's not just on a boring poster, but it's all the information you would normally put on a poster, just presented in a different way. Here we have a comic book. So the Adventures of Iron Morgan, and she turned herself into a superhero comic book. So we have the shield would be the Bohr model. And then as you read through it, it describes all of the information that needed to be on there. And then what she couldn't get in the comic book, she made a glossary. So over here we have the atomic number, the chemical symbol, the atomic mass, and all those were actually written in the book. She just wanted to clarify it. The shape, crystalline shape, what it is, the group that it's in, the density. We had a student that made, I thought this was really creative, cereal box. So we had Bismos for bismuth, how he related to it. The nutrition facts had the numbers that were the atomic mass, the atomic number. Over here, the ingredients. So this is a little description about him and how he relates to it. I have nickel. The student related himself to nickel. If you're going to do something like this, just make sure it's not a perfect circle. So make sure that you use something to make it into a circle. But all the information and facts, I thought this was pretty creative. I have a cake. It's a little hard to see, but here we have a cake. And then as you take out the pieces, that's where all the information is. We have lots of scrapbooks. And the information, again, it's all the stuff that you would normally put on a poster or a slideshow, just being a little bit more creative, colorful. Here's another scrapbook. All about bismuth. Here's a brochure. So hopefully this gives you guys a few more ideas in addition to the ones that I've already given you. This is supposed to be a very fun project. Hopefully you guys learn a little bit more about elements by doing this project. If you have any questions or if you have any ideas that you need to run by me, please let me know. Or if you need any materials, I do have some cardboard and some other stuff in my classroom if you need any of that. So just let me know what you need, how I can help you, what you need help with. Hopefully this clarifies everything. So I'm looking forward to seeing all of your finished projects.